All right, everyone. Welcome again. By a show of hands, who came out earlier this week on Tuesday to the intro talk? Great. Okay. So, for those of you who didn't, it is also going to be posted at some point on my page and the Codex page.
Yeah, on YouTube.
Yeah, on YouTube. And that's going to show you some really great examples of where Python can be used, why it's a really mature language, and how you can get the most out of it. For this first of 3 workshops, we're going to look primarily at the basic features of Python, how to get some things running, some basic quirks, as well as installing packages and actually creating your own command line utility. And bear with me because I have not prepared anything for this at all for this particular workshop, except knowing exactly what we're going to do, because I want to go at the pace that you guys are comfortable with, and feel free to ask me or any of the other 2 people who are helping any questions at all. I personally love tangents, and the best tangents are the ones where I don't know the answer. Okay, so hopefully everyone has installed Python, and not the version that came on your system if you are on a Unix system. So, if whether or not you installed via Anaconda or the standalone Python installer, you should be able to type Python or Python 3 into a terminal command line. If you're on Windows, just go ahead and you can go ahead and start just running idle, and that should be fine. But it should come up with Python 3 point something. Do not run 2 point something. Python 2 has been around for a very long time, but it is end of lifing at the end of this year. So please, if you're just getting started with it, do not start using legacy Python with only 4 months left to go. So Python, unlike a lot of other languages, is a weakly typed language. It is not compiled, which, among other things, means that we can have access to this lovely Python interpreter, where our hello world is really just print hello world, just like that. And move that up. Can everyone see that? And all that does is print out. So if you've used JavaScript before, it's like console.log in your browser. It's been so long since I've done Java, but I think it's system.standardout.print or something like that. Dot out. System. Oh, okay, that updated. Shows how long it's been since I've touched Java. But we're still in our Python interpreter. We can do anything here because Python, while Python is built on top of C, it is done on a line-by-line basis. There's no pre-compiling. It uses what is called a just-in-time compiler, a JIT compiler. So it really will just go one line at a time in the order of execution. So if you write a very long Python file with tons of if statements and try exception handling, it's only going to check that the lines are valid as you run them. So as a larger kind of example, testing is very important when you get to large code bases and large projects. You want to know what's running. But Python, it's even more important to have code coverage, because if you have even just a syntax error, if you have a syntax error that is not file breaking in a line that you don't test or you never run in normal operation, you don't know if it's actually working or not. Tangent aside. So just a quick survey. Who does not understand terminology like int and float? Okay, just a couple. So let's just go over that. and this should be a good review. So Python, when we create a variable, let's just say age is, I'm actually turning 28 on Friday, so that's fun. Variable assignment in Python, because Python is weakly typed, we don't need to use var or let or static or anything else that specifies this is a variable in other languages. And this is an integer. When you hear integer in Python, that is just a number that does not have a decimal point in it. So 1, 2, 3, 4, 0, -1, -2, so on and so forth. And if you're coming from other languages that are statically typed, this is going to bug you. Because, again, Python is a weakly typed language. What's interesting is when we're built on top, because Python by default is built on top of C Python, we can do any kind of type conversion that we want, or type override, because everything under the hood as far as C is concerned is a Python object, and that's it. Python is known, a little more advanced bit here, Python is known as a duck language, which means, the term comes from, if it looks like a duck, it quacks like a duck, it's probably a duck. Under the hood, and that C layer, Python is not checking the types of something, it just checks, does this object have this attribute? So if we try to add two things together, and one of them doesn't have .add supported, then you can't add two things together, at the very least. Just kind of coming back here. So we are able to do variable overwrites, and this is how you access variables, by the way, or you write variables. In the interpreter here, you don't need to use print, which makes certain things kind of easy. When you are running programs, you should use print to print out to the console. So we have int, float, strings. In Python, you can use double quotes or single quotes. Whoops, don't mix them together though. It does not matter. Where you would want to choose one over the other is, say, for code formatting reasons, or if you are wanting to mix them together. Because if you do single quotes, just like in some other languages, it's going to say, well, I don't know what M is because it's now outside the string. If you need to use both, Python has you can do triple around everything. Well, that should work, yeah. Don't end it with one like that. And actually, in that case, it probably would be better to use single quotes on the outside because it ends with one. So that would work too. And if you do need to, you can use an escape character. Or, well, that's a bad example. That would work too. So, while we're on strings, because I'm just going to look at the basic types before we get into collections, lists, sets, dictionaries, things like that. Let me show you how to quickly do string formatting, because it's going to be very helpful later on here. So let me set this back to age equals 28. We can do old style Python, and some libraries still support the use of this %sign operator. If you're familiar with old style C formatting, you would have I'm blank years old, okay? And that's just regular string, but There are some good things and some bad things with this. Obviously, all of your arguments going into this old style syntax need to be already need to be strings in one way or another. So we don't really use this much anymore, but some people do. What is preferred a little more recently is calling .format. The advantage of calling .format is it will automatically turn everything into a string and insert it. And if you don't, if you just leave empty brackets, it does everything in order. However, if you are running 3.6 or later, I think, it's either 3.6 or 3.7, we now have what are called F strings, where you just put an F at the beginning, and this I can now just put in there. Think like if you've used Swift before, the syntax should be pretty familiar. Maybe not including the F, and that will do the same thing. Yeah, F just stands, it's a formatted string. Oops, there goes the mic. In Python, it's actually building off of an established syntax where you can put a character in front of the string to tell the Python interpreter how to interpret that string. So in Python, if we gave it a Unicode character, like I don't really remember a Unicode character off the top of my head, so that's whatever that is. That's exactly. Yeah, it's been a while. If we don't want Python to interpret that, we can put an R in front of it. It's now a raw string. If we wanted to give this byte data, so a byte string, we might give it this, and forgive me, I don't recall bytes off the top of my head either. But should be able to do just say be an empty string, its class bytes, instead of string. So that's an established way of telling the Python interpreter what to do with a string. Since I have pulled up type, let's quickly look at Python has a bunch of built-in functions. You don't need to import anything in order to use these things. Type is one. We've already looked at print. And print, I can do print age. It will print out 28. That will work in regular Python programs or not. Type will tell you what type or what class type an object is. There's a really helpful command, especially when you are just starting with Python, called dir, dir. And that will tell you everything that is associated with that object. So age is an int. Now, at least down here at the very end, bit length, conjugate, denominator, so on and so forth. These are public methods, whereas everything above is either private or they're called dunder methods. In Python, is the colloquial term. That just means that they start and end with a double underscore, dunder. And dunder methods, and we'll get to this when we touch classes a little bit, just tell Python how to use your class with Python built-in things. So for example, this dunder EQ tells Python how to handle does age equal 28. Under the hood, it called that dunder EQ. So just a quick example. Trying to think of what else I can do with ints while we're here with this age. In other languages, especially C and Java, you might be familiar with something like ++ at the end for incrementing. Python does not have this. It's a syntax error. However, there is a lovely syntax in Python where if it's my birthday, we can do age plus equals 1, and I'm now 29. That is syntactically equivalent to age equals age plus 1. But the nice thing with plus equals is I can also say that I aged up 10 years. I'm now 39. Now, what do you think would happen if we have minus equals?
19.
I'm gonna go back to 29. What about age star equals 2? Ta-da, I'm 58. Exactly. And not to exclude that, divide equals, I'm now 29.0. That was unexpected there. Well, in Python, if you do just regular division, it's going to give you float. That is actually different from Python 3. Well, different from Python 2. In Python 2, if you divided anything, it would do integer division. If you for people who are not familiar with it, a lot of older style languages, when you divide something, will do what's called integer division, which is everything minus the remainder. So if we, in Python 2, if we did 7 divided by 2, it wouldn't give us 3.5, it would give us 3. Obviously, if you're just starting programming, if you want to divide 7 by 2, you expect 3.5. Older languages do not do this. If you want to get that back in Python, use backslash to do integer division. And one last bit, and you don't usually need to do this under normal circumstances, but 7 mod 2 will give you the remainder of 1. And I swear most of the time you will not actually need to use math as a programmer. Any programmers in this room know that programming is mostly not math. But it's a great way to show off just, here are some fun things you can do. It's basically a calculator. Yay. It's a very expensive calculator. Okay. Oh, and just while we're here, let's do 2 to the power of 3 is 8. That's just how you do exponential. If you need more mathematical things, there's the math module where you can get more things, but we're not going to get in there. Well, actually, let's just do import math. You guys don't need to do this. I just want to pull up math.py. If you need more math, there's more math. Okay. Let's see. Let's look at while we're talking on Python quirks, if you are coming from, how many people say have JavaScript as their primary language? Okay, a couple. I actually was expecting there to be a little more. And this is also true for other languages to some degree. For Boolean values are just true and false. In Python, bool is actually the type here. So it's class bool, that's our type. In Python, true and false are upper and lower case. You might have saw that up here before when we did this age is age equal to 28? True. And false, they're both capitalized. There's also the null object. Most people will use null. Python has to be different. It is none. And none doesn't actually print anything out, so we're not able to do that, but we can do t equals none. T has no value. for optimization purposes in Python, there is only one null object ever at a time, which makes some things really interesting. So if I did a equals none and v equals none, now normally if we did, let's just say b equals 1, actually I'm not sure if this is going to do exactly what I want. So actually, let's do c also equals 1. That's what I was going for. So we can do, b is equivalent to c. It's checking the values, and 1 is equivalent to 1. So yay, it's true. But if you want to check for things like, are these objects referring to the same thing? Actually, that's not a great example then. You use is. Actually, instead of looking at the value of the variable, it's looking at do these two variables look at the same object in memory? So if you're going through a list and you want to say, is this object in this list? And it's more complicated than just looking for equivalence, you would use is. A quirk of Python is that it is more efficient to do something like t is none, which in this case is true because they are the exact same object because there's only ever one null. It's not exactly advanced Python, but it is definitely a quirk in Python. Okay, so int float kind of looks a little bit at strings. So let's look at a little more strings.
Can I ask you a quick question?
Yeah.
Does the spacing matter in certain languages? So you kind of have b equals 1. What if you didn't have space in between? Would that matter?
B equals 1. Does not matter.
Okay.
Most of the time it does not matter. Python spacing is significant, but only white space at the beginning of a line to have indentation. And we'll show that very soon. Let's just look a little bit at strings. So we had that string formatting before. So I have a string. If we run dir on our string again, we have a lot more things that we can have fun with. In that, running dir on it, we have a lot more public functions that are designed to be used. If you're coming from other languages, there is no such thing as a private function in Python. There is no such thing as reserved. Because Python is just-in-time compiled, it means that all of the source code must be available on the machine it's running on. If you are a company, that means your secrets must be public. So you either need to compile into a C library and obfuscate it, or anyone can see your code, which for debugging is great. Anyway, so we have a string here. Let's look at the find command. We already looked at .format that's in here, but our string is hi there. So if we want to find something inside of it, let's just say we want to find the first occurrence of a space inside of our string. We can do .find, and it gives us the index where it can be found. So let's say, well, actually, this is a good segue into indexing. So in indexing in Python, for anything that is considered an iterable, we use our bracket notation, similar to other languages as well. So the first occurrence of a string was at index 2. Python is also 0 indexed, like C-type languages. And that returns us the character at index 2, which is in fact the space that we were looking for. We can also say I want everything up to but not including that space at index 2. So implicitly, this is what it's doing. And even more implicitly, this is what it's doing. This is just saying that from our string, I want to go from the beginning up to but not including index 2 and include every single character. That would just give us hi. So, or explicitly, that's what it was doing. Implicitly, That's the exact same thing. Those are just default values. And also, if you just want to grab the entire string, that will do the exact same thing. Because the default values are start at the beginning, go up to but not including the character after the end of the string, and include every character. If we wanted to, what we know to is our space. We can do start at the third character and go to the end. That will give us there. Or let's say we wanted to grab every other character. Doesn't make a whole lot of sense, but there are times when you might want to do that. And that is indexing for anything in Python that is an iterable. So going into what's another example of an iterable in Python? Well, that's a list. So we can have a list of a bunch of number elements. And for you statically typed people, that might also drive you insane. Totally valid. So just like we could do with our list, everything up to but not including the third index, that would give us 1, 2, 3. And we can also take every third element. Well, only 1 starting at that. Or yeah, actually, let me get rid of the 3. There we go. 1, 4, and 7. Obviously, do not go beyond the bounds. Index error, just like anything else. Let's also dir our list object here. So we have index, which will give us the index of the first occurrence of anything we give it. Pop will remove something from either the beginning or the end of the list. There's no put, but we can insert something at index 0. We can reverse a list, we can sort it, we can append. We'll probably be using append later on. Append is just, I would like to add something to the end of the list. I'm just going to add 4. Now we have 4 at the end. Remember that plus equals from before, where we were just adding adding a new integer to our number from before? Well, we can do that exact same thing. We just give it a new list with some elements in there. We can plus equals a list. We have now added elements in a list to the end of our list. Now, that doesn't work because that's not how we're removing elements from a list. If you were trying to think of, well, how would I handle removing this list from another list? You can't do it. It's not supported, and it will give you that error. Kind of going just back to looking at our dunder methods. We can do plus equals because it supports add, but we can't do minus equals because there's no dunder subtraction in here. So dir, whether you are just learning the language or if you are just using a new object or you want to remind yourself of, can I do something? You will end up using this a whole lot.
I have a question.
Yes.
Is there any way here to see what arguments one of those, I don't know if they're functions or what you take?
There should be. So there's.
I'm fine with just having elsewhere to go to find it.
So my favorite tangents are ones where I don't know the answer. I know that there are help docs and there is ways that we can, for example, this l.append, we can run dir on that because everything in Python is an object. Everything in Python is an object. Everything in Python is a first-class citizen. For people that aren't familiar with the term, a first-class citizen is anything that you can supply as a parameter to a function. This function here is itself a Python object of sorts, and we can run dir on it as well. So I can get this l.append.dunderdoc and that tells you what that function does. It appends an object to the end of the list. I'm kind of curious what some of these other ones in here are, because I don't tend to actually look around for this stuff in there. Actually, okay, so text signature this is telling you the parameters that it is expecting, or at least what the developer has called them. You can ignore this self bit in here because append is a class method. Self is just a self-referential reference to the object that is being acted upon, and we'll look at that at classes later on. But object is the thing in the is the parameter name for the thing that we are adding. Yes.
Can you run help on list append?
Yeah. So we should. Yeah. Help is a built-in. So we can do. Let's. Help list gives us a whole bunch just to get to it. And this is actually really nice. This is showing you just the doc definition. So there's our add, self.value, returns self plus a value, contains. And these are all dunders. Again, these are things that tell Python how to use this object with the built-ins of Python. Now we have append here, so append object to the end of the list. There's our self object, and then the end. Clear, copy. We can count the number of times something occurs inside of a list. There's our insert. Here's examples of a default value in here. So pop, remove and return an item at the index, and by default it will pop and return the object at the end of the list. But if we give index equals 0, now it's popping at the front. For computer science people, the difference between a stack and a heap, or not a stack and a heap, first in, first out, or first in, last out. Python doesn't have any specialized method to handle that. It just matters, do you call pop or pop index equals 0? That's all. Remove, reverse, sort, and we'll actually look at this key equals none bit later, because that's a nice thing to know about. Oh, there.
Can you say that the first in, first out?
Oh, so in computer science, the way how you handle queues. If you've been to Disney or Universal, when you get in a queue, you really hope that if you're the first person in, you're the first person that's getting taken out of that queue. But you can turn a queue into something that's called a stack, where the first thing that comes in is the last thing that gets taken out. And some languages have things like push, make a difference between push, pop, pull, whatever they want to call it. In Python, there's just .pop, and then you specify, do you want to pop something at the end, which is the default? Do you want to pop something at the beginning? Or do you want to pop something that's just by whatever index you want? Yeah, that's all that is. Okay, so we can do, or we should be able to do help.append, and that just sends us straight to the function or the method definition there. Okay, so let's look again at our I'm being really bad. I'm being a bad programmer for this, because I'm not using descriptive variable names. When we get to our program, we will be using descriptive variable names. Just rather than my string, my list, my whatever. Okay, so let's actually pop for the sake of sorting, because Q. Just type Q. Yeah, I'm not a Vim or VI guy. I like my Nano, so even I forget the Q to quit things. I'm a bad programmer. No. So let's just do s.sort. I have a feeling that this is going to fail. Yeah. So attribute error. Sort has no attribute. Sort. Actually, I'm also a really bad programmer because I just called string.sort and it's not going to sort all my characters for me. I meant to do list.sort. So there's our list. Here we go. This is what I thought was going to happen. So for the strongly typed folks in here, you're going, there's a string in that list of integers. We can't do that. You absolutely can do that, but there are certain things we can't do because Python doesn't know how to compare an integer and a string against each other. If we had a whole bunch of strings, or we could even go in and override the equalization function of an int. Like we really could just do class int. That probably might break it, but we just or actually not even that. We really could just do, Nate, do not type this down. We're not doing this. But just an example. We can do int, we would be able to do int eq equals, again, really bad, but would work. Python, in Python, lambdas are just functions that don't, they are abstract functions. In other languages like JavaScript, they might be called closures. So, especially in JavaScript, if you make a web call and then you do .then and you give it brackets, that's a function definition. That's a lambda in this case. But we would absolutely be able to override whatever the equalization function is to then support comparison between string and int. But I'm not going to do that. That's just an educational example. Okay, so let's use that pop. So we can do list.index just to find where that string is. It's at index 7. So we can do l.pop. Remember, l.pop is also going to return it. So we give it index 7, and it returned our object. It removed it, and it returned it. So if we wanted to say do, my num equals, l.pop7, that not only would that remove it, we now have it assigned to my number, and we'd be able to use that in the future. But yeah, L, we now have all ints, which means we can do L.sort. Doesn't return anything. It's an in-place sort. And for computer science people, I believe it is using bubble sort, no, it's using a version of quicksort. Yeah, it's whichever. It's yeah. I think I was just pulling at straws with the bubble. Yeah, it's whichever one will work for the majority of cases, even if it's not the fastest in your individual case. Probably merge sort. I want to look this up now. Let's merge her quick. Yeah, it's using merge sort by default. Okay, computer science back down. So that is an in-place sort. There's also a built-in command, a built-in function called sorted, which if I'm going to go ahead and overwrite this with just a whole bunch of other ints. I can do new list equals sorted list, and that new list is now sorted, but our original list is not. That means both of these are now two different things in memory, but we have access to both. Question?
I noticed you're using commands with how does it, what would happen if you have two lists, assigned to two different variables? How is it deciding to use S?
The sorted?
No.
Oh.
All the commands.
Oh, okay.
You're putting the command in without an argument.
Oh, like L.sort, right?
Yeah.
So in Python and other languages, this L.sort dot sort is not. It's the difference between. So list is the type, and in this case, actually, list would need self, but it's not really how you're supposed to use it. List is the type of the class that we're using, whereas L is an instantiated object. So when we call L,
That's not my question. My
Okay.
question is, you type L
Mhm.
and it uses S. How does it figure out to use S? What would happen if I have S and T both string or both lists?
oh, well, so when we call L.sort, it's only going to run sort on the object L. Yeah.
Oh.
So
You type L.
So if I want to run sort, if I want to run the build that sort method on new list, now I do new L.
Correct.
Again, this is me being really bad with naming variables.
Simply type L. It will return that list, correct?
Yep.
How does it decide which list to use if I have multiple lists?
Okay. So earlier we typed L.sort, and it sorted, granted the one list I had in memory, but it was L. So if I want to run sort on the new list that we created, now, and again, both of these are in memory.
Right.
New L is already sorted, so let me just append a new element to it. So if we have new L in there, we have an unsorted list technically because there's a 3 at the end. I can do new L.sort, and it just sorted new L. It did not go ahead and sort L.
Okay. So when you type L there, you did not specify an argument. How does it conclude to use new one?
It's not.
Yeah.
L is the list. He's got two lists. He's got one.
L is just
Yeah, I don't think he saw what he defined with L.
Yeah.
What happened to that?
Yeah.
Maybe reference types are both pointing to different.
Yeah. So my cool list is a variable that is pointing to this list that has 1, 7, 3, and 5. So I can type my cool list now, and it's pointing to that, is only pointing to that particular list.
Type L.
Mm-hmm. If we type L.sort,
No. Type
If-
L.
type L, it's not my cool list anymore. It's a different variable. Yeah.
All right. I'll have to wait until you use another command if I'm confused.
Yeah.
I didn't realize that L was your list.
Yeah. So just like we had age before, so this is a better example because I am describing a variable that I can look at that and go, oh, whatever the value of age is, it must be an age relative to whatever I'm working in. Now, I haven't defined a variable called year. It doesn't know what year is. But if I say year is 2019, it now knows what 2019 is, or it now knows what year is, and it has a value of 2019. And then, while it wouldn't make sense, I can add both of these two together. I now have a new element, which is surprisingly relaxing value. I don't know. I'm trying to think of that square adding game. Yeah, very close. Be 2048 and zero indexed. Yeah, we're just that's just defining variables. You Another thing that's going to annoy people, my statically typed friends here, is we can overwrite anything we want. So if I accidentally say, hey, this is a list here, that's now my list. I don't know, like a type list is of type list, but I now no longer can access my type. So be careful that you're not overwriting things. And for the sake of cleaning that up, I'm going to quit and restart that. Yeah, there are certain things that you can and cannot overwrite. Anything that is a Python object and not something meant for control flow, you can overwrite. Obviously, that you cannot overwrite because that's not a type. That is a control, or it's an if statement. Okay. Any more questions before we move on?
Just real quick, just because of the list equals, like,
Mm-hmm.
is there a reason why they didn't go with capital L lists and stuff for their objects like everybody else?
So I can't tell you why the built-ins aren't capitalized. I can tell you that because they are not capitalized, they stand apart from user-defined class types. So in Python, the convention is that your variables are all lowercase. And while people have their opinions, they would use either lower camel case, or most people use snake case, underscore snake case for variables, for methods, for functions. In Python, the standard is when you're defining a class, you would make it all upper camel case. That means that as long as you know what the built-in types are, the base built-in types are, it's really easy for them to stand out. And on top of that, I know this is supposed to change in the future, but Python, in the last handful of versions, has introduced typing into the standard library, and those actually do use uppercase. So I can do from typing import lists, and you guys don't need to do this. This is just referring to the type of something. So we'll see this later as well, because I use function annotations everywhere. The proper way to do a function annotation, to do a type annotation, is to use these uppercase ones. But that's for one reason or another, that's not what they did with the built-in types. That's really it. And you can see that too if we type. Let me create age again. If I run type on age, it's going to give me lowercase int. And anything that's a built-in type, that will work. And if I do my class chest, I use chest. Actually, and even then, this is an explicit. Everything in Python is an object. You don't need to do that at all. You don't even need to do that at all. And just to put something in there, and just pass does nothing, but it tells Python that you didn't actually you meant to skip this line. So technically, I have a class chest now with nothing in it except for the built-ins that we get from it being a Python class to begin with. But I can just do C equals chest. It doesn't take anything. I now have an instantiated chest object, and that is uppercase. And for any custom or user-defined classes, it's going to be upper camel. Okay, so we looked at lists. Let's very quickly look at set. Set is just like a list. So I can make my list here, like we had before. Oh, and by the way, in Python, you can end any kind of collection or certain line breaks with an extra comma. Python doesn't care. So a set, oh, actually, before we get to set, tuple. Python loves tuples. A tuple is just a list with items that you cannot change, or not with, is a list you cannot change. It's tuple. Oh, well, I'm not going to do that. That's so, tuple. You just use parentheses, and that is a tuple. If we try to change an element inside of T, like, so this is index assignment. So just like we had before where we would, or, we can take a subset of a tuple. It's just a collection, just like anything else. And in a list, which I did define a list up here, we can do assignment, or just like we can access, here's the first element of the list, we can also overwrite the first element of the list, or any element of the list by index, just like that. So we do L again. Instead of it being 1, it's now 2. However, if we try to do this with the tuple that we created, we get an error because tuples cannot be changed.
Is that because tuple is clarifying tuple because it doesn't have a variable name to it?
No. So well, tuple is specifically meant to be unchanging.
Okay, so when you did parentheses 1, 2, 3, it doesn't have anything for that.
Oh. So I did assign it to a variable t up here.
Oh.
Yeah. For these collections, there are a handful of ways that you can explicitly specify them instead of just doing tuple. For the list, we used square brackets.
Yeah.
Now that we're using parentheses, that says this is now a tuple.
Okay.
So that's really the only special thing, that's really the only special thing about tuples. It's a list where you cannot change it. Or you cannot change the references, the objects inside of it. Advanced Python, if we have a tuple with lists inside of it, you cannot change out the lists, but you can change out the elements inside of those lists because tuples do not then retroactively, or do not override all the objects inside of it. If that doesn't make sense to you, then don't worry about it. There's some weirdness when it comes to accessing and changing elements in lists, or in lists, sets, and dictionaries when they have a. We'll get to that later. I'll have a great example.
Sorry, you mentioned that Python loves tuples,
Mm-hmm.
and I wonder, is it because they take in space, or what?
So Python loves tuples because it is a built-in way to return multiple objects from functions.
Can you elaborate on that? Just
Yes.
briefly.
Yeah, very very briefly, and we'll still get to functions in a little bit because we got plenty of time. When we create functions in Python, and here's the example. Here's our first example of, or I guess second, because I used it with class, of where whitespace is important. Whitespace is only important in Python at the beginning of the line because that specifies the indentation level. If you are just getting started with programming, it is a great way to teach and force you to remember indentation levels. And then if you go to a language that Python is really the only major language that actually has whitespace as an important element. Most other languages do the bracket syntax or something similar. But now I have def my func. I'm now inside the function, so I need to put spaces or a tab or whatever. So now I can write let's just say I want to return 1. That's pretty similar to other languages. It just returns something. In Python, if, let's say this function returns 1 and the string s, that is totally valid. If I call my func, it returns a tuple. So you'll see this a lot, and we'll see this in the third workshop because we're going to be using Flask. Well, actually, I don't think Flask doesn't use this. There's a web framework called Falcon that when at the very end of the response handler, so if you call get, you use the get function. The last you need to return the response and the number corresponding with the status code. So if it was successful, you would give it, here's the thing I want to return, comma 200, or error 500, 400, whatever. And you'll see this a lot, and we will probably bump into a built-in function at some point that also returns multiple things. But that's just how Python loves tuples, because you can return multiple objects.
They're not meant to be changed, so that's why.
Yeah, exactly. And they also take up the least amount of space. If you think about what's going on under the hood, because we are still running on top of C, languages that do more hands-on memory management, programmer hands-on memory management, you need to specify, I want to create a list that I can put 10 things inside. With Python, when you create a new list under the hood, or I don't know if this has changed, but it will create a list with a default length that is sufficiently large enough where it will not need to expand that list in the C layer. But when you create a tuple, because there's only n number of objects that will ever be inside of that tuple for its lifetime, they then specify, oh, they want to create a tuple with 2 objects in it. I'm going to create a list internally with just those 2 objects. Exactly. So tuples are more memory efficient. There's also a fun thing, and I should remember this myfunc because we'll get there as well. Actually, let's talk about that right now because we are talking about tuples.
One question.
Yeah.
Is return the same thing as print?
So return is I'm returning something from a function. Print is I am printing something out to the terminal.
Okay.
So when this return, if I had used print, these elements inside, it would print to the console. But if I called, I'm just going to say f. Now let's do n myfunc, and then call n. It's now, yeah, exactly. It's myfunc is assigning to n what it returns.
Okay.
If I called print, it would print it during my run of that function, but n wouldn't get anything.
Gotcha.
Exactly. And question?
Did we go over how the REPL is printing things out? Like if you're actually running a Python script, it would just be printing everything out like this.
We haven't.
That might be a little.
I mentioned at the beginning. If we do print n in our Python interactive prompt here, print and just typing the thing out are going to do the same thing. When you're actually inside of a Python function, just typing n isn't going to do anything. You actually need to print because now you're in a runtime. This is just special handling that makes it really easy to play around with something and to learn how the language is handling things. So thank you. I think we had some people that walked in after that. Okay. So another great thing with tuples, especially dealing with functions, is we did look at, if I want to grab the first thing out of n, we just use our bracket and the index that we want to pull something out of. However, in Python, we can do things like age year equals 2019. We can, like some other languages, we can do multiple assignment. So I'm sure these were already in there, but that works. And you can string together as many as makes sense to put together. Don't abuse it. A good example would be something like assigning lat long. And that's actually a great example. So let's say that I pulled in, or I have a coordinate that is a tuple, because coordinates shouldn't change, of, let's just say we're on a grid of 1 and 2. Well, if I wanted to get access to each of these elements, I could do coord 0 and coord 1 with our index brackets, or I could say, well, my x and my y points are the coordinate. So if I do x, it's 1, and y, it's 2. So this is tuple unpacking. Or, well, it's just unpacking. You can do this with any iterable. Now, in this case, this makes sense with a coordinate, and I just want to refer to these the elements as x and y. Coords, let's go back. Coord still exists, but now so do x and y. Now, what we can't do is, if I was expecting coord to be in 3-dimensional space, but it only gave me 2, well, now I have a value error. Not enough values to unpack. Because we specified x, y, and z, it was expecting 3, but coord only had 2. In Python, Python is better than some other languages when it comes to presenting these exceptions and figuring out what went wrong. It's not as good as some other languages, especially new ones, because new ones like Swift and I think Kotlin to some degree as well, they will give you, did you mean to do blank, or here's exactly what went wrong. Python, again, these things are bubbling up from C, so there's only so much that they can do. But learning how to read exceptions is going to be very helpful. Okay, so we have variable unpacking there. Now, back with L. So if we wanted to grab, we could do A, B, C, and D to grab all the elements out of that list. But let's say that I only want to grab the first element out of the list, but I also want to remove, or if I only want to grab the first element, like let's say I am reading in a CSV file, and the first element is the index that got exported from a database or something. So let's say our CSV row, and it probably would be read in as a tuple. Just let's say we have an ID of 1, name is there we go. And we have age 28, and then just some random number that might be time spent playing Skyrim. Well, there's my row. But let's say I wanted to access that ID at the very front, and then access the rest of the data by itself, not including the row. We can do tuple unpacking. Oh, and by the way, here's ID is a built-in. Most people have no reason to ever use ID, so I have no problem overwriting it. This is the last time you're going to see the ID built-in function, and we've never even called it. And if you're wondering, all ID it does is it tells you the ID in memory of an object. Most people do not need to know that. I have no problem and have never had any problem overwriting ID. Okay, so we pull out the ID, but then what do we need to do to keep the rest of it minus ID? We can't use row and then just we can't do that because it's going to say expect too many values to unpack. It expected 2, but row does not have 2 elements in there. Not to mention we're trying to overwrite it as well. What we can do though is we can put a star in front of it, and all that does is, well, you gave me a variable, or you gave me an iterable row. I'm going to pull out the first item here, and then I'm just going to put everything else inside of this one. So if we do row, that's now everything from our original row minus the first element. And probably should have just called it data or something different. But let's say, so we're back here at row. Let's say I want to do that same thing, but I want to grab, the most important information for me is the first element and the name. So I want to do ID name, and let's just actually call it data this time. What do you think that's going to do? Yep. So now data is just everything, not including the first 2, and ID again is our ID and pulled out name.
So how does it decide, say for example, name? Is it because of the position that you're putting it on?
Yeah, it's only determined by the position inside of it.
So if I instead wanted to grab age, say for example, how would I go about doing that without giving it an index?
So you could continue this, doing this, because we have that age in there. Well, we could do that if you needed to. At some point, if they're not all together, or they're not the beginning or the end, you will eventually just need to do age equals row 2.
So are you basically just giving each item a column name when you're doing that ID?
Kind of, yeah.
Okay.
Yeah.
I know
So
you mentioned CSV file initially.
yeah, that's exactly how we're doing it. We're treating that column name. We're just assigning it as that variable name.
Okay.
So we could be iterating through an entire file, a CSV file, and then it makes it really easy, this ID, name, and then the rest of the data to say, okay, well, I know exactly what this is now. And this is also the example of using descriptive variable names.
Okay.
It's like, yeah, it's just like putting a column on something. Question? Okay. So here's something really crazy, and this is something that they added in somewhat recently to Python. We can also do, that's starting from the beginning. Let's just say I want to do, I want to keep the data at the start of the list all in data, but I also want to access something at the end. We now have access to hours, and the rest of the data is just the rest of the data. That's going from the end. Something that they added into Python somewhat recently is the ability to, let's say the only thing that we care about is the ID and hours. We can do that too. So now data is everything that's just in the middle. And you don't use, even in my experience, you don't use this all that often, but when you can, it's really nice. So that's tuple unpacking. And kind of bringing this all the way back around to our, I think I called it, so n. When our function from before returns multiple values, we can just automatically unpack that data. So number is now 1, and the text that it returned is S. Okay. Long tangent, but tuples are really cool and they're used everywhere. And I also covered unpacking. So, a set is really simple. A set is a list of elements that do not repeat themselves. In Python, we use curly braces when creating a new set. And if I repeat any elements, like 1 is in there twice, it is now unique. And if elements can be sorted, they will be sorted. So in Python, the simplest way to deduplicate a list is to convert it into a set. And if you need it to be a list again, you just convert it back into a list. So I think we still have L in here. We updated the 1 to a 2 earlier, so it has 2 2s in there. So we can convert, let's say we needed to deduplicate this, but also continue for it to remain as a list for one reason or another. We can, first it's going to do whatever is in the first set of parentheses. So it's going to cast our list L to a set, which is going to duplicate it, and then it's going to convert it back into a list. Ta-da!
I did S equals a curly that didn't absorb.
Hmm?
I did S equals when the curly bracket.
Yep.
And it didn't absorb.
So you just did
S equals.
that?
No, I did S equals bracket, random numbers.
Mm-hmm.
And then it didn't sort.
Get someone to help him out.
Shouldn't really matter anyway, because that's also part of the set is the
Yeah.
Yeah, he's got it right. It just doesn't seem like it.
It's not sorting it for him. I know I'm running on the most recent version, so maybe they changed it at some point. Okay, so 3.6 is sorting. Maybe make sure you're not running on Python 2.
No, it's Python.
Python.
Yes, 3.7.
3. I don't know.
7.7
Sorting is just kind of a nice additional thing. If you really need to sort a list, just call your list.sort on it, or sorted if you need that. And that's really all there is for sets is just a list that has unique elements. If we so we have our set here S. Instead of there's no such thing as append. If we run dir on S, there's no append in here, but there is add, because we can add elements to a set. So if we try to add 2, it doesn't really matter because 2 was already in there. But if we try to add 9, we now have 9 in our set. And if you need, and then there's also other things like our unions, and there's equivalency things like is a subset of another set, things like that. So the last major collection type, iterable collection type, is a dictionary. From other languages, this might be, other languages would call this an associative array, or if you're coming from the JavaScript side, it is an object, a JavaScript object. Or if you've used JSON before, it's basically the brackets syntax in JSON. If you're coming from JavaScript, an object in JavaScript is not equal an object in Python. An object is equivalent to this dictionary, whereas an object in Python is technically everything. An object is just an instantiated class in Python. That's just the terminology. Hey, so a dictionary, we use the same curly braces as our sets, but instead, let's say we have our age is 28, and name is, insert your name here. That is a dictionary. Now, a dictionary, instead, for our list before, we access objects in our list by their index. A dictionary, or associative array, we access by the key value. So in this case, we created a dictionary where age equals 28. You can think of this as a data store. It technically is all data stores, but it's like making a web call. You would get a dictionary. We can access the different values inside. Like d.keys is going to give us just a list of the key values. Same thing with values is just going to give us the dictionary values. And items will give us tuples of the key value pairs. If we need to add something new to a dictionary, like let's just say the hours again from our row example earlier is just something there. Then if we call d bracket hours, we now have access to that variable, or that data. And rerunning keys again, we now see we have hours in there. Any questions about the basics of a dictionary? Is the main difference is instead of accessing things by their location, we're accessing it by some other hashable value. Usually it's by strings. Okay. So this is now a good time to go into this is now a good time to go into loops. For people coming from other programming languages, well, we know what a loop is. A loop is just a way to keep going over multiple items inside of something, or while some condition is true. So if we wanted to go through, we have our list L here. If we wanted to go through all of the objects in our list here, Python reads like English, which is great. So I can do for number in L, print number. And notice that spacing is going to be, or you do need to put at least one space in front of print, because that is setting the indentation level. That means that we are inside of our for loop. So we go ahead and run that. It goes through every element in our list, 2, 5, 2, 7. And there's no number is just the variable name. I could name this for n in L. It doesn't actually know what number is in that case. It actually is just referring to number from the previous loop. Print n, there we go. Nothing special about it, just specifying a variable name. We can do our subsets like that. So if we only want to iterate, we only want to iterate through the first 2 elements in our list, we can do our subsetting like we did before. If we want to iterate backwards, here's a fun thing. So when remember that our implicit values in here are this to the end, which by the way the end is technically kind of, well, it's the end. Let's just say it's the end. In this case, we have a thing of 4 elements, so technically index 4 is the end of the list, and then that is what we're doing explicitly by not including it at all. How do you think that we can iterate starting from the end of a list to the beginning? -1. Now, we get rid of that. We still need to include those, but -1. Print. Now we're going backwards through a list. If there's another way of doing that, which is there's a built-in function called reversed. That's going to keep happening. Does the same thing. The only difference is reversed is like sorted, where it just returns a copy of the list, just in reverse order. Technically, that's also what's happening up here with this, but you would use it in different cases. Okay. Now, what do you think would happen if we do, let's just say for item in our dictionary? If we print item, what do you think is going to happen? So I heard the right answer over here. It iterates through our keys. So for an item in D, the most important thing in D, or in a dictionary, are the keys that allow you to access the values inside of it. So instead, actually, instead of for item in D, it is more accurate to say for key in D, and then I can, instead of print key, I can access D key, and now I am printing out the value. Print can also take multiple things in here, so if we want to print both, there. Now we have key. It puts a space in between the different elements that you provided it, and now we have key and value. But let's say that we wanted to get both key and the value. How do you think we would do that? Remember that if we do key value, we are doing unpacking. Anyone remember what a function or a dictionary method returned the tuples of key value pairs? Items. So d.items. And now instead of calling d key, we can do value. And now we're printing out the keys and the values. We now have explicit access to both from the definition of our for loop. Okay.
Question. If I change, let's say, name within the for loop, and I assign something else to it, is it going to mutate it in the list, or is it just going to be in the scope of the array? In the scope of the loop.
So we have you can make changes you can make changes to val all you want, and key. They're not actually affecting the values inside of the dictionary. They're technically copies. Actually, I don't. Well.
Those are always defined by reference.
Yeah, I think there's actually so here's some Python weirdness, and this is why this question is vexing me right now. Let's say I add a new element to D. I'm just going to be lazy and call it list. And I'm just going to keep it empty. For D.items, So, just stepping through, which has happened there. So we still have for key val in d.items. So we're creating copies / references to our key and value values that are inside of our dictionary. This if is instance. If is an if statement that says if something is true, then proceed to do the next thing that is further indented underneath this if statement. So if the value is of type list, which the only element in here would be the value associated with the key list in our dictionary, I'm going to append 3. Now, if I do d-list to grab the element out of there, it has a 3 in it. Here's some Python weirdness. This is more of an intermediate level thing, but if it can trip up a beginner like nothing else, because Python is weird in this case. Languages have a concept of pass by value or pass by reference when creating something new, like setting a parameter into a function, like we did my set.add 3 or val.append 3. We're giving it just a value of 3 to that function, but if instead of 3 we had a variable called my number equals 3 and then we append my number, pass by value would say I'm going to copy the value of this, which is 3, and then put it into that call to the function. Pass by reference would say, pass by reference would, instead of copying the value of that parameter, I'm just going to give you a reference internally to reference the same object, my number, which is equal to 3. The weirdness that comes up in Python is that discrete values, like the values of strings, integers, floats, booleans, and the none type object, these can be thought of as pass by reference because a 3 is a 3. But when you pass collections, like lists, like dictionaries, maybe even like tuples, that's passing a reference in. So this for key val in d.items, this val is in fact the reference to that list. And if I make changes to the list val, it is going to make changes to the value my list inside of that dictionary. And it's going to persist because that list remains inside of that dictionary. The weirdness comes when it's not an iterable. Well, the weirdness is the iterable part there. If val was an integer and I did val plus equals 1, I'm just changing the value of val. I'm not changing the value inside of that dictionary. That's one of those weird things, and this is not an isolated example, or this is one of many examples of this kind of iterable, non-iterable weirdness. A lot of things, like most of the times, this exact functionality trips up people when they put an empty list as a default parameter in a function, because now if you change the actual variable inside of that function, well, now your default variable of that empty list now has items in it for every other time that someone calls that function. Or if you initialize a class that starts with an empty list and you put it in the class definition, well, now every time that an instance of that class adds something to that list, now it's also accessible to every other instance of that class. And as a junior programmer, when I first started seeing that tripped me up like nothing else. And why is it doing this? I said, start with an empty list. Why aren't you starting with an empty list? it will drive you insane. I do not expect people to remember this after today, because that's just kind of it's an intermediate level concept of just why that is the way that it is, but it will trip you up as a junior programmer like nothing else. So I'm very glad that this is being recorded. Okay, so that's a basic for loop, and that really is all there is to a for loop. We also have this if statement in there, which I'll break that down in just a second. The other main type of loop in Python is a while loop, and if we do while true, this is going to run forever. So I'm not gonna put anything in here and click enter, but we can do, let's say, just I'm gonna be a good C-type programmer and say I. That's a convention. So I can do while I is less than 10. We're going to print the value of I, and we're going to I plus equals 1. So this is going to say, every time that I go through this loop, I'm going to print and add 1 to I. And we're going to keep doing this until I is greater than or equal to 10. 0 through 9. We printed 9, it then added plus 1 to get to 10. The while loop said, oh, I is not less than 10, so I'm now going to break out and we end the loop. Your two primary loops in Python. Your operating system is running on a perpetual while true, to some degree. We'll look at more loops later, but that really is all there is to it. Yeah, there are other places where we can use a for loop. Let's look at a quick built-in function called range. So we have a 0 through 9 here. Let's say I wanted to create our list again with 0, 0, 1, 2, That's a really common thing. So we're going to create a range object that goes from 0 up to but not including 10. And it technically is a range object. This is different in Python 3 than it was in Python 2. In Python 2, when we called range 10, it would give us a list from 0 through and including 9. In Python, we now have these wonderful things called generators. A generator in Python is something that you can iterate on, but it does not keep all of that information in memory. So whereas a list, 0 through 9, has 0, 1, 2, and all the way up to 9, a generator, our range 0 up to but not including 10, every time that Python calls for the next object, it calculates what the next object is. So it's much more memory efficient, for example. So we can do for I in range 10, if we print out I, we're going to get the same thing. If we can go from 5 up to not including 10, and I'm going to be really lazy, do not do this. I'm just going to put everything on one line there, which you can do if you only have a single indented flow, loop, whatever, in Python. So that will do 0 through 9. Or if I wanted to go from 0 through up to but not including 10 and do every other, that gives me all the evens. Or if I have a reason where I want to convert that range object into a list, well, we can just convert it into a list. Now, instead of doing, for our for loop from earlier, okay, so I think we actually still have row in there. Yeah. So we can do for item in row, we're going to print the item out. And that gives me all the elements inside of that data row, or that CSV row from earlier. But let's say that I just want to iterate through the index. Like maybe I want to selectively update an element in there just by the index value, and I want to iterate over that. I want to update maybe every odd element in there. What we can do, there's a built-in function in Python called len, where you can give it anything, and if it implements the dunder len function, it gives you the length of that element. So in this case, our row has 4 items in it. A len returns 4. I can call len on strings. It gives me the length of that string. So I can call for I in range len of row. What do you think this is going to give me? No. So it's going to give me the indexes. So it had our row had 4 elements in it. Len returns 4. So we now have a range 4, 0 through, but not including 4. So instead of doing print I can access by index the elements in our row. So I can say at I, here's our value. But there's another great built-in Python that actually takes care of that syntax for us much more cleanly. So again, we have variable unpacking. I can do for I val in enumerate row. And instead of calling row I over here, I can just, our val has been set in our for loop there. Same thing. And just to add one more level on top of this, I can call reversed on it. No, I can't. I can convert it into a list, though, because a list is reversible. Ta-da. Probably not many times you need to do that. I actually have one case where I need to do that. So we're using our built. Actually, we should be able to do this. No. No, because main is a. Let me quickly look this up because I know there's a way you can do this. There is a way to actually dir all of our built-in things in here. If you actually want to look, the Python docs are pretty nice for the standard library. This is what I was trying to build to call just with the dir function in there. But this is absolutely everything that you get without having to import anything in Python in terms of functions that you can call, types that are available. Like here's our int, here's our list, there's len, converting things into a bool. There's our set. We can zip, or we can look at zip a little bit. We called type a handful of times. There's our tuple. There's enumerate, is instance from that, checking if something was a list. So if we see Ooh, what is this? What does max do? Returns the largest item in an iterable. So this is assuming that the things can be compared again. So let's just, I wonder if I can just give a range object. Yep. So in a generator or anything that can be iterated through of 0 to 9, well, 9 is the highest. We also have min built in, 0. Yep.
Take a break. Yeah, do you want to give everybody 15?
I'm being told to give you guys 15. So 15. All right, before we start getting into functions, we're going to get into functions, classes. Going to look at 1 or 2 libraries from the standard library just to show some things that are in there. Then we're going to do a pip install and start building a very simple command line utility. But first, I had some people asking for some resources. Number 1, I feel obligated to mention pyorl.org, as in Python Orlando, or Orlando Python. That takes you right to, the meetup that I co-organize. Shameless plug. The next one is coming up in about 9-10 days. We meet on the 4th Tuesday of every month. We do record and live stream all of the meetings. So if you can't make it to the meeting, it's live.pyorl.org, which takes you to the YouTube live stream. Obviously not running right now. And everything, and all of our past videos are at watch.pyorl.org. We have about 3 years worth of content, including, towards the end of it there, we have the last time that I ran a beginner series, about 2 years ago at this point. So if you need a refresher on this, on these topics, and this video is not available yet, you can come down here, beginner series 1 of 3. These segments are only about 2 hours long, so we go through we went through the content even faster than we're going through now, if you can imagine. But also some other fun stuff in here. We built a Flask web app together, testing, had some Django stuff in here. At the January or February of this year, we did a live coding session in just under 2 hours where we built an entire web app that could accept payments. I love live coding, if you can't tell. Okay, so there's that. Now, if you just type in, say, Slack Python, if you, as a junior developer and even as a senior developer, Slack, while it might be the bane of your existence at work, is really great for learning and connecting to other people. I think it's actually I know the group is called I think it's called Python Slackers. pyslackers.com. That's what it is. So this page will do an auto invite into a global Python developer community Slack. And I do, in fact, have it up here. Please do not open on Disney. Thank you. That would have been bad. Okay. Python developers. Let's make this full screen and bigger so everyone can see. So, you have any questions on data science? Well, look, there's a big data science channel in here. Testing, conferences. Let's just look up junior. Well, no, I spelled it wrong. It's pyslackers.com. You need that has a link to auto invite you to the group. But there's a bunch of things in here, in internationalization options. There's a job board, job advice. meetups.
Oh, this isn't already in T.
Yeah, so you can find all sorts of things, and there should be a channel. Yeah. Game dev, if you want to write any games in Python. There's a lot of games in Python, actually. There is also, in the Orlando Dev Slack, we have a Python channel that someone said, "Sup, my dudes." If you want to get into this one, find me or, oh, he's not here. There's someone else had a Orlando Dev shirt on. This is an invite-only one for Orlando developers. Find me afterwards. We will get you the invite, and then join the Python channel. There's also a juniors channel. So if you just have questions, junior questions, you'll talk to a bunch of other people, and there are some seniors in here that are able to answer your basic questions, like how do I get started with GitHub? Which, by the way, if you want to become a developer and you don't have a GitHub account, do. That's very important. Then there's, if you want other resources, I always highly recommend Code Academy. They have a free Python course that is available to teach Python. If you need a mentor, you can find it on there, as well as they also have projects, standard projects as part of their curriculum that can be reviewed. But I would recommend their free course to start off with. So, getting back into our code. So at this point, I'm going to, we're not going to be in here anymore, because when we get into functions and classes, they get a little more complicated than what would be reasonably, or than what would be reasonable for a single line-by-line interactive Python session. So I have Visual Studio Code here, which is my preferred code editor. If you downloaded regular Python, it should come with, it's not idle, but there's a different code editor. You can also just use whatever code editor or text editor you feel most comfortable with. If that is Notepad, use Notepad. If you're on a Mac, TextEdit. Just whatever you want. So I'm actually going to do this. So I actually have a code shortcut on here, which opens up a Visual Studio Code editor on my desktop here. Okay. So we have an empty file here. Just to show that everything is working, I can do my hello world. Save it in the desktop. I'm just going to call it main.py. You can call it whatever you want. There's no special, main is not a special keyword in what I name my file. I could name it demo.py. I just had a file up called demo.py. Just whatever you want to call it. But main.py, I have my integrated terminal here. As long as you're in the same directory, like I could go into the desktop there, and we'll just do that again. I can do Python, main.py, we print out hello world.
So how do you get the terminal from VS Code?
Hey, in VS Code? At least on a, yeah, so, yeah, up top you can do view and then terminal in the options.
Okay.
I'm not sure what the quick key is on Windows. On Mac, it's Control-tilde. Does that? And that's all I really remember how to access it. So thank you for the view.
Thank you.
If you installed Conda, that's what that's what this is doing right here. Well, that in this case, we also have the Python/Anaconda extension running in VS Code that will automatically open it. And we can specify different environments here. Like I'm actually going to open up my workshop environment. If you don't have that built in, if you have Conda installed and you just want to get into, or no, we're going to be fine in base. We'll get to that later. As long as you can type your Python and then the name of your file and it runs, we're good to go. And if you don't have an integrated terminal, as long as you are in the same folder in both your terminal where your file is. So here's my main.py. I can type main.py, same thing. And for anyone that is not there, if you have any more experienced programmers around you, please ask for help.
I do. With my Visual Studio, I'm trying to show my terminal. It's not showing. Top is not showing.
It's installed.
Go to View on the menu bar on top, and then Terminal should be about halfway down the list. Yeah.
Okay.
Just gonna give it a little more.
Is everybody back?
Yeah.
Ask your neighbor.
Maybe. He's just walking back in.
So everybody here, who has programmed before? Who is a professional programmer, has a job as a programmer? Who is looking for a job as a programmer? Who has never touched code before today? Thank you. How's it going so far? Doing well? Are people helping? Yeah. Fantastic.
Perfect.
Cool. So Eddie, is the recording ready, or did you already start?
Yeah, we've been going.
Okay,
Yeah.
cool. I'll let you get back to it.
So is everyone at the point where you can run a Python file?
Yes.
Just one way or another, you can run a file. Okay. And it sounds like people are getting help where they need it. So let's move on just a little bit here. Now to the point that came up earlier where we were doing, I'm going to get rid of our print hello world. Let's just say, all right, let's use age again. So age equals 28. If we print age and then we just type age, this is only going to show up once, just 28, because we are no longer in the REPL. It's not doing that nicety for us. Essentially, what this line does nothing because we're not doing anything to or with this variable. So it doesn't know what to do with it. It skips it. So now that we have a file, we could question.
So in the terminal, when it does Python and main.py, it doesn't run the file. Should it be different than Mac, or no? You should be able to see
You
that.
should be able to. You could, if the terminal is in the same directory as main, it should be able to see it. If he's on Windows, you might want to run on PowerShell instead of the old style terminal.
Is it to run that and show the age down the terminal? You just go to the terminal, do run selected text, run task.
So for the
Yeah, when you do main.py, you did age equals 28.
oh,
And then you do
so age equals 28, and then we just print it out.
age, and then it should show down here. 28.
Yep. So if that's the content of our main.py, All it's doing is setting a variable age equal to 28, and then we are printing out to the console, which is or to the terminal, the value 28.
My console's not just showing 28.
I'll try and help if you want.
Okay.
So.
Yeah, this is going to be the most individual part of the workshop, but it's very important.
The double click to get the term. The start of the time.
Oh, VS Code?
Yeah, to get this thing. Because it has the effect.
I'm so
Put the path and then but you have to do Python.
Some people I just add
Well, that's okay.
Oh, it is.
But I'll do freelance things like build somebody a website.
Second, because I
But I don't really do just like
with all this stuff.
freelance. Whatever, code to an app. It's more for all permanent clients.
I think it's the same.
They trust me.
Maybe in some.
If they don't have any, I pick them up.
I think because the installation
I'll try to get them.
So checking back in, is everyone able to run a Python file, or are we still waiting on a couple people? No. Let's wait around this way.
Yes, I'm doing it. It says it's done.
Looks like you did a pip install.
Oh, what kind? I saved the file here.
Oh, go ahead and switch back to the first one on there. I think this is doing, it looks like it's trying to do Kylint
Okay.
install.
So do what? Switch number
Yeah,
one?
yeah, switch to number 1. Yeah, so type Python main dot, space main dot py. And then,
A couple of my larger clients are using.
oh, you don't have, interesting, you don't even have, Python doesn't even look like it's there.
They have their own. Right. I just take all that. My biggest one's actually have a lot of more. No, I used to work on it.
Oh.
Probably.
Oh, okay. So you do have the Python executable in there, but it's not available to be found as a shortcut. But it did install Pilot there. So at least for the time being, we can do. We should be able to do. Okay, so now we're actually running Python here. Oh goodness.
Yes, yes, kind of like keep finding what's most profitable. But it's nowadays, you know about programming, everybody's trying to get away.
Okay. That's a little more complicated than it used to be, but what that is doing is it is going to the actual Python executable, and to get back to that, all you need to do is press up, and it will take you to the previous command. So
Press up and do what?
pressing up will take you to the previous command, and then you can just click enter again.
Okay, thank you.
It just didn't put a shortcut in there yet.
Okay. Oh, I have to go into environment variables and add it, right?
Maybe do an alias or something like that. Yeah.
Yeah, I forgot about that.
Living in a Unix world.
You can do it if you want. You don't need to.
Yeah.
You want to ask if anybody needs help?
Anyone need any more help? People that can go around the room? Are we just waiting over in the back there? So, in the interest of time, we're just going to start looking at functions. Most people, it seems like you're able to run this file in one way or another. Okay. So, pressing on. Earlier we had a myfunc, which we defined like this. Let's just say we return 1. So in Python, we def is used to begin the definition of a function. Just what does a function do? So def myfunc is the name of the function that we are creating, and the brackets specify any parameters that we're going to supply this function. In this case, the brackets or the parentheses are empty, so this function takes no parameters. And the last thing that a function needs to do is it needs to return something. In this case, we are returning an integer of 1. We can also return nothing, or we can return nothing. Technically, that won't work, but if we pass just is this line does nothing. Because we're not returning anything, we don't return anything. It's a null value. But return 1. Now that this function is defined, we can just print out myfunc, and we need to call it. So we have our parentheses. It does not take any parameters, so we don't supply any.
I have a question.
Question?
If your return does not turn Heap, is that
Oh, yeah, this is just syntax highlighting. This is a nicety that comes with a code editor as opposed to something like a Word doc.
So with functions, you always return at the end.
Yeah.
And that's how it knows when, because there's no brackets or anything. That's how it knows it's the end.
Well, actually, that is a good question. So what isn't being shown here is, notice the indentation level went back to the beginning, went back to the very start of the line.
So spacing matters?
In Python, spacing matters. Not spacing in between characters or spacing at the end of the line, but spacing at the beginning. In JavaScript, you would do func, my func. You would give it parameters, and then you would need to give it curly braces like that, and then that closing curly brace indicates the end of that function definition. In Python, because we don't use curly braces to indicate function definition or classes or anything like that, it really just is the indentation level. I pressed tabs and it inserted 4 spaces. As long as your indentation level is consistent, then you shouldn't have any problem. And text editors nowadays do this for you for the most part. Do not mix tabs and spaces in Python. And I think a lot of code editors' default for Python is when you press tab, insert 4 spaces. You can also just have it be 2 spaces as long as you're consistent. And down here, you'll even notice spaces equals 4. I can indent using spaces, indent using tabs. I can detect that it's consistent. These are some niceties that I get from my code editor. But I can also change spaces set to 2 or convert everything into tabs. Just as long as you're consistent, it doesn't matter. So there. And this actually. Okay, so if we run this file again, it printed out 1, which is what the function returned. We want to make this a little more. If we just do this, print out num. So now we're just assigning the value that was returned by my func to num, printing it. We get the same thing.
What do you click to run it?
Enter. Yeah, so in the terminal, as long as the thing that I want to run is there, you click enter, and we've now executed that command. So, like we did before, functions can return multiple things. So my func in this case returns 2. We're now printing out a tuple of 1 and 2. We can use the unpacking like we did before. Now let's look at function parameters. Let's say I'm going to just create an add function. And this add function takes 2 numbers and just adds them together. This is the same as saying 1 plus 2, except we're doing add with, let's just say n1 and n2. And we're going to return n1 plus n2. So we're going to add 3 and 4 together and just print the result. And that should print out 7. Prints out 7. Now, why would we use functions? If you're not a programmer, functions kind of seem like, well, why didn't we just do n1 plus n2, or why didn't we just do 3 plus 4 and print that out? It's because we can reuse functions. So rather than just doing the result, I'm just going to do print. And I'm just going to copy this a whole bunch of times. And I'm just going to change that up. We've now reused the exact same function. Imagine we have a really complicated function, or never write complicated code, write complex code. It's not a fine line, but a very nice reason why. Functions allow us to take code and reuse it very easily. Now, this is totally optional, what I'm about to say, but this is a readability thing. When you write code, we can write comments in code. In Python, we use the pound or hash symbol to do comments. Yeah, this is a comment. This is just a note to the developer that is looking at this code. It's not going to do anything in our runtime. Has no impact on the actual runtime of the function. But comments and a bunch of other things are there, not for you right now. Or personally, code readability is not about writing code for someone else to look at, like some other person. It's you put in code comments and other readability things to remind yourself in 6 months from now what the code is supposed to do. Because chances are, no one else is probably going to look at your code unless you're doing code reviews or something like that. But you, especially when you're learning, you're going to be referencing your own code a whole lot. So the easier it is to remind yourself in the future what your code does, the better. So with functions, the first thing we can do is we can put in a doc string that tells us what this function does. This function, add, adds two numbers together. And if you remember from our help and our dunder doc from before, that's exactly what this is. It pulls up this string. This is a known common syntax in Python, and you are able to access it via add.dunderdoc doc.
Triple quotes for multi-line?
Yeah, triple quotes is for multi-line. It's single or double quotes, doesn't matter. And again, does not impact the runtime of our function at all. Another thing that is available as of Python 3.5, I believe, 3.4, 3.5, and if you're not running Python 3, chances are, if you haven't been tripped up by now, you will very soon here. And if you're not running a more recent version of Python 3, this will also trip you up. I briefly mentioned before function annotations. This is what this is. In other languages, in strongly typed languages, this is where you would put the expected type of the variable being put into this function. Java, C, Swift, most languages are strongly typed, and they would actually raise an error if you call add with something that is not an int. In Python, this is for readability's sake. There is no type checking at all. You can enable type checking by running a third-party library like MyPy, but again, it is entirely optional. This code has no bearing on our runtime and will not protect us if given bad information. We cannot add a string and an int together. However, as long as we give things that can be added together, it will still work. Function annotations are there to remind you in 6 months or more from now exactly what you intended this function to take in and put back out. If we have a function called add, and it tells us in the doc string, here's what this does, here's the types of everything that I expect to be put into this function, and here's what you get back out, we don't need to remember every single detail about how this function does it. This is why this stuff is here. So for the rest of the workshop, I'm going to be using function annotations. Oh, and by the way, this is returns an int. I'm going to be using function annotations and doc strings everywhere. You don't need to for the workshop, but I would highly recommend it. If you have the time to type it in, do so. You're going to thank yourself. And once we get to the towards the end where we build a little command line script, that code is going to appear in a GitHub repo with everything we're going to build starting then and towards the end, all the way to the end of the workshop. So you can go back and reference the code that I've written, and it's going to have all this information in there. Okay. So we have add. Now that just adds two numbers together. Let's say that I have an int, and by default we can give n2 a default value of 2. This is how you do default values in Python. This just allows me to say, if you give me 3 and 4, I'm going to add 3 and 4 together. But if you only give me 3, I'm going to add 3 and 2 together. So default values are overwritable. And from my ranty tangent earlier about the Python weirdness with iterables, if we make this an empty list there, or any other kind of iterable, this is another instance where that if we do n2.append, it is now there for every subsequent call. So don't do that. Please don't do that. But there's one other place I mentioned that is a common issue, but just kind of pulling it back there. So that's a default value. Default values can also be accessed via name. So I can do explicitly n2 equals 3. We can do that too. And then even positional values, I can explicitly call n1 equals 2. That works as well. If you make everything a positional argument, or everything a keyword argument when you call it, it doesn't matter what the position is, it will work. This is actually changing a little bit in Python 3.8, where people can explicitly make things positional arguments, but I'm not going to get into that.
What's best practice?
Best practice is, if it's a positional argument, then just leave it as a positional argument. And if it's a keyword argument, if it's a commonly used keyword argument and it is positional in nature, then you can leave it as a positional argument. But if it's not, then for readability's sake, keyword arguments are the way to go. The only time when it is required is if I have multiple. I'm just gonna put something in here. The only time when positional versus keyword is required is if you are trying to set the value of a keyword argument that is not in the order that is defined in the function. So with this, I'm just going to set this back to, it's going to take 3. I'm going to say n2 equals 3, and I called it item. Item equals false. That item is not going to do anything. That should run fine, so we add 3 and 3 together. But if I don't give it n2, if I just say item equals false, that is going to use the default value. But if I just say item, I want this false to be item, but in the function definition, the thing that is in the second spot by default is n2. So this is actually going to fail because we cannot. I was thinking it's going to fail. However, I did not, because we kind of skipped over if statements and truthiness in Python. There is the concept of truthiness in Python. So in Python, false is phrase, and I'm not even in Python right now. Here's where you get to a nicety of Python. Even though we're working in a file, if I just need to quickly see if something works, I can just open up a Python interpreter and just see if something works. False equals 0. That's true. These are both truthy equivalent to each other, because in computer speak, true is 1, false is 0. That's false because none is not truthy to anything else. But you know what else is false? And okay, I'm getting my truthiness a little confused here. False is not equal to 0. False is truthiness to 0 because false is technically 0 in bit speak. However, if we do an if statement, like, I'm going to go back here because it's a little higher up on the screen. So back in our if statement. So in other languages, you might have parentheses around things and then do that to actually handle it. In Python, we have the same kind of syntax. Or in Python, we do the same kind of syntax we have with our for loop, but we also don't have any parentheses. So I'm just going to have a value. It is true. If val is equivalent to true, we're going to print yay. And val is actually equal to true, so yay. And the same thing if we set val equals to 1, 1 is also truthiness true, so we're also going to do that. Now false is false is false, so if something is false, then we're not going to do the thing in the if statement. 0 truthiness is false, so we're not going to do anything. Now the difference between equals, Boolean being kind of a weird example with 1 and 0, truthiness, pretty much any object can specify truthiness. So if an empty list is truthiness false. An empty dictionary, an empty iterable of any kind is truthiness false. And included in that, empty strings are truthiness false. Any non-empty string is truthiness true. Any non-empty list is truthiness true. It's the kind of thing where if we had a function, and actually let's put this together. So instead of this item, let's say we have a thing called. We're going to get rid of this. I'm going to say we're going to overwrite the sum function in Python. Sum takes a thing of items. So we're going to call it a list, and it returns, for the sake of our overwrite here, it returns an int. And if we wanted to be even more explicit, a good programmer that wants to use the typing module for something like MyPy, you don't need to type this down. This is just kind of showing off. From typing import list, if you wanted to make it fully type compliant with that library, you might do a capital L list int returns an int. Personally, I do not run things through MyPy. And because annotations are not evaluated, they have no effect on your runtime for the most part. I personally will do it like this because that is a list of int to me. And remember, your documentation is, in one way or another, is primarily for you in the future, unless you are working with a giant team. So this sum of items takes a list of integers and returns an int. So sum's a list of numbers. We have, let's just say our value starts at 0 for number in items. I plus equals number, and then we return I. So with our slightly more limited definition of, or just based on the types that we expect to come out of this, we have overwritten the built-in sum function. And I actually need to get rid of that. So we have numbers, and we're just going to call this range 10. And we want to print out the values, well, print out sum of numbers. So when we run this, let me get out of here. 45 is the sum of 0 through 9. So we're now combining a handful of features that we've gone over so far. This is a pretty nice example because we are combining a function here with all of our documentation that we've written for ourselves. We're using a for loop to iterate over a list of numbers, and we are adding them to an initial count of 0 to build up the sum.
You have to put the I equals 0, or would it work just by default?
Well,
Zero.
if you don't, you have to put the I equals 0 because we're defining what I is.
Inside this function.
Yeah.
As opposed to
And if we try to print I out of here, because I was defined inside of that function, we do not have access to I. And you'll actually notice even without running it, my code checker is saying that I is undefined. We are not returning the variable I. We are returning the value of I. But then once we exit out of this function, we just call it. It doesn't know what I is anymore. This is standard handling in most programming languages, but just wanted to make it very explicit that that is what is happening. Now, let's notice how this print statement, I can do the sum of, and let's actually use our formatted string format from before. We can do the sum of numbers is, we can do that, and that is now super descriptive. The sum of range 0 through 10 is 45. If we actually want to print that out, we can cast it to a list. The sum of 0, 1, 2 through 9 is 45. And if we just print, we can also just print numbers and then some numbers. And we can just add things to this all we want and just run it. And it can accept as many arguments as possible. There is a way to do this in Python. So instead of, let's say sum, instead of handling a list of numbers, let's just say we want it to handle as many numbers as we give it, just in the call to the function. Remember our variable unpacking from before? We used star. Well, we just add a star here. And now, instead of some numbers, actually just going to comment this stuff out. We can just call sum with 1, 2, 3, 4, 5, and it will print out 45. So star can be used in a handful of places, and it usually indicates either packing or unpacking in one way or another when attached to a variable name.
So star always returns a list? Always converts it to a list?
Yeah, star will always convert it to either a list or a tuple. I'm not entirely sure. We can actually just run it. We can do print type. I think called it items.
Does the star have a specific
So
name?
it's a tuple. No, not particularly. And
So that's like the same thing as the splat operator in like other languages, right?
yeah. And there is a way to do this with keyword arguments as well. Not going to change the function. All we do is double star. And we'll look at this when we get into the classes here in just a second. Instead of giving it a list of arguments, whenever we give it a key argument, it's going double star. We'll put it into a dictionary for us, so we can access them via keyword arguments, or we can access all the keyword arguments as though they are a dictionary. So that's all we're going to do. That. I'm going to create a new file, and because I used it earlier, and I'm pretty certain I also used this at a Python meetup somewhat recently too. I'm going to create chess.py, or no, not chess.py. I'm going to rename this just so I'm not doing a Java-like thing. Let's do game.py. Now in game.py, we're going to make an adventure game. And in the adventure, we're going to find a bunch of chess. Now, classes are a way to build a common, or classes are a way to store and act on information that can be used with multiple instances of something that all act the same way. So if we create an idea of what a chest is, we can create unique chests inside of a game. In Python, a class starts with class. We give the class a name, and if we wanted to do any kind of inheritance, then maybe if we created a game object with special base properties, that's where we would do that, but not for this. So class chest. Classes can take have doc strings as well. So we have a doc string there, and the chest can contain a number of items. And if this is a chest containing gold, then we can specify that our items are of type, a list of ints. Let's say we cannot divide gold into pieces, so we can the minimum value of a piece of gold is 1. Well, that's an int. Now, classes can have methods attached to them. A method is a function attached to a class. It's the exact same thing, you just call it something different. If you say a class function, people will know what you're talking about too. So here's our first dunder method. Whenever we create something, when we create a new object in Python, you'll notice that back here in our Python shell, list is a class list. If we want to create a new list, like what we were doing for creating a set into a list or a range into a list, that kind of thing, we give it some kind of iterator. It happens to already be a list, but bear with me. And we create a new list using this parameter syntax. This is initializing a new object of type list. So our first dunder method for our custom class is going to be dunder init, initialize. The first thing it takes is self. And whenever you are writing a regular class method, the first thing the first parameter should be self. You don't need to call it self, but you can call it whatever you want. But this is a Python convention that the community has agreed upon. When I say self, I am referring to the object. So chest, when we initialize, we can initialize with items that are of type list of ints, but maybe we want to, if we want to create an empty list or an empty chest, then we can go ahead and provide a default value of none, as in the user did not give us anything, and we don't want to use iterables as default values in our function calls. Do not do this. That's that weird error from before where, yeah, do not do this. We use none. So, oh, and then we end with a colon, just like our function definition. You don't need to give an init function a docstring, because unless someone's calling init on explicitly looking for a docstring for the init, there's not really a reason to have it. But that's more of an opinion. But what we can do here, we can do, let's say, if items is none, then items is an empty list. So this is handling that weirdness of do not have default empty lists, or do not have lists or any kind of iterable as a default value. And we are using this is none because there's only ever one none object in Python. This is slightly more memory efficient and speedier than doing equals equals none, or we can also do if not items, which would also apply if the user supplied an empty list. But maybe they supplied an empty iterable of some other kind. Just kind of digressing. Anyway, then once we know that we have something, we can do self.items equals items. And now whatever the user has supplied this chest with initially, that is what it contains at my chest.items. And we can actually look at that right now. So I'm actually going to launch the Python interpreter down here. Now because yes?
Oh, question. Before you get too far back on what you said with the is none, is there somewhere that you can find, I guess, like a repository of time frames that compares those as far as like to know that equal would be slower than is none? Is there somewhere like that?
I actually don't know. I've seen a lot of different blog posts on, well, like, why is this feature this? I would love, maybe I'll be looking for this between now and the next workshop, but just kind of a lengthy list of Python gotchas and best practices, like stuff like that. I will tell you that if you want to know this very poetic description of Python and how you should write Python code, this isn't going to help you as a beginner in terms of syntax, but there is the Zen of Python, which is kind of your commandments for Python, written at the written very early or early-ish in Python's development. PEP stands for Python Enhancement Proposal. People can make PEPs to make propose changes to the Python language. The Zen of Python is only about yay long. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. It's kind of just a set of mantras. This is the closest thing that I can go to of here are some general best practices when working with Python, other than if items is none. I will be on the lookout for that, though. So readability counts. That's why I was pushing the readability. If you can't read your own code, then there's no way that anyone else is. There's just absolutely no. And you're not writing for anyone else. You're writing for future you, who's not going to remember. Hey, future you is going to look back at your code and go, man, I was really stupid. So you can at least say, well, what was I?
What did I do?
Yeah. Why in the world did I did this? Oh, there's a note in there that says, hey, future you, there's this weird error. Don't do this. Oh, thank you, past me. There's one other great one in here. Yeah. There should be one, and preferably only one, obvious way to do it. Although that way may not be obvious at first unless you're Dutch. That is in reference to the guy that created Python language at the beginning. There's one and preferably only one way to do things. There's preferably only one proper way, or one efficient way to do something. But the great thing about Python is that because it's been around for long enough, if you think you can probably do something, you probably can. Where we've shown before, I can do for I in range len object. But if I just need to grab the things in there, well, I can do for I comma val in enumerate objects, and that's a better, more clear, explicit way of doing something. Right? To come all the way back, I will be on the lookout for 107 Python gotchas or something like that for the next workshop. Anyway, so so this terminal is in the same directory as my game.py. So I can actually import game right now. And I now have access to my game.chest. Ta-da! Class game.chest. I can create a new chest object. And it has, a total of 6 gold in it. Chest is not defined. Game.chest. So I now have a chest object with some items in there. We've used our initializer. Now, if I have, I'm going to create a new chest, game.chest, and I'm going to give it nothing, so it's empty. We still created it. It's still there. C1.items, it is now empty. And we can compare C and C1. They're not the same thing. Or they are not equivalent to each other, even though we haven't written that yet. It doesn't actually know what's going on. So in fact, if I actually set C1.items, and probably you don't want to do this if you were actually building this game. If I do C.items equals C1.items, they're equivalent to each other. They both have a list of 1, 2, and 3. But what if we wanted to check if 2 chests were equivalent to each other? C equals C1. Well, no. So remember, in Python, equals is not looking for the same object in memory. That's actually the is. C is C1. That's looking for object for memory equivalence. Anyone? So we already looked at 1. Anyone? Do you know what we need to do to interact with native Python features with our classes? We use a dunder method. So if we want to check if 2 chests are equivalent to each other, we have a dunder EQ, where we can take in self, and EQ also takes in another chest. And for the sake of because in this I use string chest here because technically we are still defining our chest and chest does not exist. If you do chest without the stringify here, it's actually going to give you a object is not instantiated error, something like that, because it doesn't know what it is. Anyway, this returns a bool, and we are going to check if self dot items is equivalent to chess dot items, and we actually need to return that because this creates a Boolean. We need to return that Boolean, and now we should be able to actually check if two chess have the same gold, technically in the same order. So there's actually there's a better way to do this to get to, but for the sake of not having to create all those objects again, we can absolutely legally do C1 equals chest with 1, 2, 3, and then create a copy C2 with chest equals 1, 2, 3, and then we can check C1 equals C2. Now remember, I actually need to put this in print because it's not just going to print that out to our console. If I exit out and run game.py, these chests are now equivalent to each other. But you'll notice here's some weirdness. If I go back to just my Python interpreter and I import game, it just ran our print statement. It created the chest. It did everything in that file, and then imported it for us. Well, before being able to import it into my current session here. If we have something that we want to run, if the file is being run directly but not on import, Python has a check for if name equals main. This is this kind of weird looking syntax because Python does not have an explicit "this is your main." This is a cheat syntax that is common and agreed upon to check if this name is the file being run by Python. So if I save this and run my game.py, it's going to create these two objects and compare them against each other, and we get true. But if I try to import game.py, because we're not directly running game.py anymore, it doesn't run that code. Some people will use this for quick testing, like this, if we would just want to test if some things are available. You could be able to run that file directly, but it won't run that test code if you are trying to import it. But make sure you're in the same directory. Can you also do Python game.py?
It's already the Python console.
So you need to do quit there. So we're now back out into Python, and then we can. Well, we can. How are you running Python?
Just
oh yeah.
Shift enter.
Well, you need to be in the same spot. I'll also make sure to save your file. Yeah, save your files if you're following along. Oh yeah, that's great. If you're using VS Code or some other kind of code editor that has a note to say save, notice how on the top game.py, the tab, when I start typing, it now notices that the file has changed. It gives you some kind of indicator. In this case, it's a white dot. If I go ahead and save the file, that white dot disappears. It means that whatever I'm looking at is currently the file on disk. So thank you for pointing that out. Okay. So we have a chest. We can initialize it. We can compare it with other chests. And let's put a public method on there, which is we're just going to I was thinking public method or static. yeah, let's put a public method like we're going to add a new value to the chest. So first we give it self, and then say the value of the gold that we want to ask. We expect it to be an int, and it returns nothing. So it adds a gold, adds some gold to the chest. Self.items.append the value of the gold. So now we can do print C1 equals C2. We're initializing them to have the same values. Then we can do C1 dot add a new thing of gold, which is 6. And if we do print C1 equals C2, this should be different because now they contain different amounts of gold. So the first time was true, we added new gold, now it's false. And last quick little thing on the classes here. We also have the ability to calculate values. So this items guy up here is a member, it is a value of the class that just contains things. And then these are our methods down here. If we want to have something, and notice that when we were down here, we can access our methods by doing c1.add6, parentheses 6. We're calling a method on this class. If we want to access the items, we can do our c1.items. If we wanted to have a value that is just a value that represents this class, but we needed to calculate it, like what is the value of the chest? Well, the value of a chest is the sum of all of the gold in that chest. So in Python, we can do our def.value, and it takes nothing because it's just a value. But we have this syntax, which is called a decorator. It is an @ sign and then the name of the function. In this case, it's a property. What this allows us to do is we can apply property to a method that takes nothing and just returns a value. And this value is the value of a chest contents, and it returns the sum of self.items. So the value of chest is the sum total of all of the gold in that chest. Now what this property allows us to do is, instead of calling something like c1.value and then it calculates it, we can just call c1.value because of that property decorator. So if we run this again, the sum total, the value of our first chest, is 12.
Can you run through that again, because I do not see where the decorator makes a difference.
Okay. So if I remove this decorator at property on here and try to rerun this again, .value is what's called a bound method of chest. It's not the actual value. If we wanted, because again, functions, like everything else in Python, are first-class citizens. So it is itself an object. If we wanted to actually call value to get the value without this, it still takes no parameters, because anything that we give value is not changing the value of the chest. So we can call value. It's still going to calculate 12. But with property on here, we can treat .value as though it were just a property of the class as opposed to a method that we need to call and calculate. It's still calculating everything in there. but it looks much nicer, it acts much nicer.
Find it kind of makes it local to that class.
Well, everything is still local to that class. It just means we don't need to call it explicitly with the parameters whenever we want to access it.
Not like a function, but
Yeah, it still technically is a function, but we can treat it in the code as though it were not a function. Yeah. It's like a runtime property, runtime value. Okay, so I'm looking at my time here. Question in the back. Mm-hmm. And I'm going to put this code on GitHub and send that link around. So starting now, the code that we write is going to be available. Okay. So technically, we have 23 minutes left. I'm going to do something very dangerous, which I plan to. We're going to, we already looked at kind of just barely importing, because when we import a library into Python, we use import, the library name, and that's it. Now we have access to everything in that library. For the sake of time, rather than looking at, I was looking to do something with requests to look at pip, and click to build something to build a quick command line tool. There's a different command line tool that I've looked at in the past, which is actually going to be faster, called begins. It doesn't seem like it's supported anymore, but it should still work. So Python, when installing third-party libraries, when you install Python, you also get a module called pip, Python Install Packager. Packager, I'm not sure which. If your Python was installed regularly, if you've been able to do just Python and then that's it, you should also have pip in there. Well, let me actually do back up here because it's higher on the thing. You should also have pip. So usage pip command, install, download, uninstall, list, so on and so forth. And in fact, doing pip.list will print out all of the packages that are currently installed that your version of Python can access. So here's pip itself. Python is itself a package. If we wanted to update pip, we can do Python install update flag pip, and now we're using pip to update itself. I think that's pretty cool. It actually went from 19.0 to 19.2, so that was needed. But for grabbing a third-party library, all we would need to do is pip install begins.
I think you start recording.
Your phone has low battery on the recorder.
Oh, recording. Okay, we're almost done. Yeah, okay, we're good. It's not your time that I'm keeping track of, it's the recording time, obviously. Okay, so all we would need to do is pip install begins, and I'm actually going to do that in, you'll notice on the bottom, if you're using Anaconda, you can have your command line, your terminal prompt starts with these little parentheses in there. That actually specifies the environment that you're in. If you have Anaconda, if you have that, it says base right now, that's fine. If you do not, as long as you've been able to run Python thus far, if you have pip, just use pip, do pip install begins. If you are on Windows and you've been doing the long path to your python.exe, don't worry, you don't need to change it. In Python, you can do python -m and then the name of the module, and you have access to all of the same stuff. So I can do python-m pip list. It's going to do the exact same thing as though I did pip list if I had access to pip directly. And in fact, there's a really cool thing in Python where if you have Python installed, you have a file server installed too. That same kind of syntax, you can do python-m http.server, and I'm now serving my current directory as though we're an FTP server on port 8000. Ta-da! Cool.
Is that pip.list like just local to whatever environment you're in?
Exactly. So for the purpose of getting this very quick command line up and running, and do pip install begins like you are beginning an adventure with an S at the end. So that will go ahead and install the begins package. And again, if you are on Windows and you're doing that python.exe, have your long python.exe, -m pip install begins, and it should also work there as well. So I'll keep that up for a second. Yeah. So remember, if you're on Unix or you have access to pip directly, all you need is this bit right there. And that is how you install Python libraries. Ta-da! Okay. Everyone either ready to go or you're tired and you just want to get out of here? I appreciate the honesty. Okay. So we have our game. Oh, I hear a what? Okay. So I have my game.py. We're not going to use it. I'm going to do CLI.py. And move that back over. So we're actually going to create our main. And let's just have our main do, let's just print hi. Now, if you don't need to type this in, but if we just wanted to run this like normal, remember we had our if name equals main. We would do main. We would just call our main function there, and then down here I can do Python CLI.py. It prints out hi. So that's our basic running a function, running a main function that we saw in chess.py. Now, to convert this into a CLI using the begins library, we first need to import begins. And in fact, this is possible to do in Python. We pip installed begins with an S, but the actual library that we import does not have that S at the end because. So we can import begin. Again, we're not using begin, but it should be able to import. It hasn't changed anything. To turn main into a command line utility, all we need to do is use our decorator, like the at property from before, begin dot start, and now we can run Python CLI.py. And we're actually printing twice here because not only is CLI.py our main, but this begin.start is running main as well. In fact, we can get rid of if name equals main, run this again, and now our CLI.py is our call to our main function. So if we give this a doc string, just called saying hi. And did you know that Python 3 is Unicode compliant? Because I can put a wave in here. I don't know if it's going to print out to the terminal properly, but let's see. Oh, yeah. So remember that main is now a command line function, which command line functions have help strings, -h. So begin created our command line utility help string for us.
Is begins using arg parse?
Yeah. So to that comment, arg parse, and actually, if I just do pip list, I forget if arg parse is actually standard library or not.
I think it is.
Yeah, that's what. Yeah. So probably just do. Yeah. So in the standard library, there's a standard Python way to grab information from the call that started Python. So arg parse. And begins is doing a whole lot of fun stuff for us, so we don't have to worry about individually parsing args and creating our doc strings for us. It's, again, third-party libraries. If you need something to be done and it's not specific to exactly what you're working on, the domain that you're working on, someone has probably already done it, and you don't need to reinvent the wheel. So yeah, we have a help string. It pulled out the doc, as well as any optional arguments. Everyone gets a help function. If we add a parameter into here, like how many times do we want to say hi? This is a times. It's an integer. And let's just say we give it a default value of 1. We can do for underscore in range times print hi. Now this underscore in Python is an agreed upon syntax saying that I'm going to ignore this variable. I'm not going to use it. Technically, at least in older versions of Python, underscore is treated like any other variable, but it's just generally agreed upon by the Python community that if I use an underscore, I do not intend to ever use this variable. And since we're not actually using I in this print, we just want something to be done n number of times, we can use an underscore. So we can come back here to our help. Oh, I know why. So this is actually begins is expecting a description, a string description. So rather than specifying int like we were before with here's the value that I expect, we can do the number of times to say hi. And if we do our help, optional arguments times the number of times to say hi with a default value of 1. So if we actually call this and we give it t or times, I want you to say hi 5 times. Oh, string out. We need to cast this into an int. Sorry, I'm a little rusty on this. So let's look up some documentation because there is a way to specify, or I already have this open over here. Python begins, and we can just look up the documentation for it. Here. So this is on PyPI. So yeah, here's our pip install begins. Again, here's import begin.start. Oh, actually, here's our begin.start. There we go. Parsing command line options. So name, there's our default values. Here's that n number of options syntax that we can use again. And building that up, so positional arguments, nights there, all of that fun stuff. I'm looking for casting. Yeah, let's actually look in the official documentation. Okay, casting, here we go. So argument type casting. we can use the built-in Python, you just convert a string to an int. If you have a string of 1, 2, you can cast that into an int of value 12. So that's what they're doing on here. However, there we can also do begin.convert to say, well, this port thing in here, when given a string, just automatically convert it into an int. So I can just copy paste that. Another nice thing is it can also just do automatic converting of everything. So if it sees a number, just automatically convert it into a number, stuff like that. So for the sake of being explicit and for time, I'm just going to do that. Just make sure that times equals int, and it should cast it to an int for us. Run this again, and it printed out hi 5 times. One more thing, so we actually put a positional argument in here. And here's a bit of Python spacing sugar. In Python, if you need something to run on multiple lines, and there will eventually come a time where you write something complex enough where you are going to use way more characters than you were comfortable using or reading, you can put things on new lines. In this case, in our function definition of main here, let's just do text. Let's actually do name. So you have to give this function a name. So this main function takes a name and the number of times, and times as a default argument. So we can do hello. We can put in the name. We didn't make this an F string. So this will say hello, name, and number of times that we want. We look up our updated doc string saying hi, positional arguments, name, your name, and then optional arguments. So if we just do CLI.py Michael, it will say hello, Michael. And then if we give it an optional argument of 5, it's going to say hi 5 times. There's a bunch of other things you can do with the CLI that you can give it you can build in subcommands, like when we type in pip and it has a bunch of commands that we can run. These are all subcommands. Begins and other libraries like click are going to treat these as separate functions. So instead of this def main, we can do def install, def download, def uninstall, so on and so forth to build up your command line. Kind of cut short there at the end. We've got 5 minutes before we are officially done. Any questions? Any ranging questions over the stuff that we've covered? Do you want to see something short and quick?
How about, can you run again through giving the user the option to input like how many times you want to say hi? Just briefly?
Yeah.
We just did it.
So we just did the t equals 5, so it would print it out 5 times.
Okay, but how do you specify that you wanted to give that optional?
Yeah.
You don't do it at all.
So that, because we're, just like with any other function definition, we're giving it a default value of 1. So for the purposes of simplicity, if we're just writing a function with no annotations, no whatever.
I guess my question is then, what is the tab T that you gave it?
Oh yeah. So the tab T is, if you look back at our help string here, the way that you specify arguments in traditional command line applications is positional arguments need to be in the same position just like a regular function call. But optional arguments, the way that you specify them in the command line is doing hyphen, if a shortcut is available, in this case -t, or double hyphen with the actual name of it. Some libraries allow you to have T1, T2, and that will be put into a list.
But that T came from the times there that you had specified as a
Exactly.
argument. What?
Yeah, the argument times, because begins and other command line utilities, things that build command line utilities, will take what you have written and convert it into what it believes is the best possible interpretation to build that command line utility. Now, let's say that if we give a default value to name, then it would become an optional parameter that would be given -n as a shortcut. And that's only because we're not explicitly saying, I want you to build a shortcut here. It's just saying, well, I don't see anything else that begins with any other parameter that begins with T, so I'm just going to automatically build that shortcut. If we give, let's just say task, a task, we're not actually going to use it, but we give it a default value of 5, just whatever. We now have 2 items in there that have T as their first character. So if we just look at the help string again, you'll notice that it only gave the -t to one of them, and it's not even times anymore, because technically task in alphabetical order was the first T thing that it came across. So that's this library making the best attempt to make some things nice for us.
At the risk of just taking too much time for questions, how would you build up something that, instead of just putting it on the one line where you're calling to the function, maybe make it more interactive so the user gets prompted, hey, can you input how many times you want to say hi?
I'm glad you asked that, because I had thought about that earlier before and scanned over it. So another standard Python built-in is called input. And just like when we're in our Python REPL here, where it has those the 3 greater than signs and a space, it's waiting for us to type something in. That's Python waiting for input. So if instead we came down here, instead of, I'm going to get rid of our task here, and I'm going to comment out name. So in our runtime, we would pause to ask what your name is. So we can do input, what is your name? And when we run this, you'll notice our help string name is no longer there. And if we just run this as is, it's going to prompt, what is your name? Well, my name is Michael. Hello, Michael. When you're a junior in programming, if you just want to test, there are a handful of ways that are easy to test things. Putting in inputs in your code, especially in loops like while true and whatnot, if you don't want to just continually be running this Python main all the time, you can put input in there and just see how it works with different inputs. For any kind of interactive user thing, input on the command line is a great way to get started with, hello, I am your magic wizard, what would you like me to do? Input. Something like that. It's also a nice way, if you were on older versions of Python, especially back in Python 2, if you wanted to have a breakpoint in your code, you could just put input in, and it would pause your code execution. You wouldn't be able to inspect your code at all, but we could do print getting name, and then ask for the name, and then for debug, I can say was given name, printing name. Like these are debug statements without going into the logging library and everything else like this. When you're getting started, printing things out to the console is better than not knowing what the inside of your code looks like. Things like this, I have a debugger. Once it's configured, I'm good, but printing is better than nothing. So if I do CLI.py again, I'm now getting the name. I was given Michael. I'm now printing the name. It prints. I'm done. So print statements are your friend to begin with. I still use them, and I've been writing Python for 9 years now. Use them when a debugger is not necessary. Any more questions? Anything people want to see before we go? Any last minute resources or?
So I did share out there's a fun little thing if you're not doing games but you're trying to automate some stuff.
Mm-hmm.
AutomateBoringStuff.org, I think it is.
Yeah.
Has a fun little free book you can read online where you can purchase it to do file manipulation. If you're trying to get your Office Excel document input without having to manually do it. Got some fun little things there.
I cannot highly recommend this book enough. The entire contents of the book are available online under a Creative Commons license. You can grab it. Automate the Boring Stuff is the go-to Python, intro to Python for, it's a practical introduction. It will introduce you to basic programming with Python in a way that you can find useful right now. If you have an Excel file and you want to run something in that Excel file that maybe Excel is taking way too long to load, or you want to export it to a CSV, well, there's a chapter in this book about dealing with Excel files. There's something in here that will find and categorize all. You can, if you have a bunch of photos just sitting on your hard drive somewhere, and they all have weird names, or you just did an iPhone export, well, you can. This book will show you ways where you can iterate through all those files and then put them in different folders by date, just as an example. I cannot highly recommend this book enough. I have a signed copy at home. It sits there. It's a great start. Games themselves are another great learning tool for Python. All the things that we went through today, like the while true loop, for loops, even the chest object that we made, even then I used it in the context of let's have a game with chests in it. Games are a great way of either through storytelling or visualization seeing programming concepts. It's very easy to see what a while true loop does in the context of a game, because as long as that game loop is running, your game is going to be running. If you want to go through all the items in a list, if you want to draw 10 things, if you want to draw 10 enemies into your game space at a random position, well, you just iterate 10 times and draw. You don't do draw here, draw here, draw here, draw here. And for games, there's a library called Pygame. There's a bunch of libraries. You just search Python gaming. There's a bunch of tutorials. There's a lot of people that are professional Python educators, either at universities or so on, that have written game-specific intro to programming in Python because it's just such a good tool. Let's see, any more beginner? I'll say Code Academy again. Check out their free course if you want a more interactive introduction to Python and to go over to keep up with some of the things that we talked about today. Real Python? Oh yeah, I forgot about that one. Real Python is, I think it's realpython.com. It is a giant tutorial blog site that they do an excellent job with all of the tutorials. Pull this Real Python. Yeah, that's exactly it. So it has topics going from I want to know where I can learn about Python to how in the world do I get this async IO library to play nicely with Django? Oh, it doesn't yet? Okay. You can find a lot of stuff in here. There's a handful of blogging sites. I can give you Python podcasts. There's a newsletter. And the CLI and game.py that were written today are going to be put into a GitHub repo. I'm going to post it on the meetup page as a comment in the meetup site. It's also linked to from the previous one in this series already. So it will be down here. I wonder if it was already linked to, no. Okay. Let's see. Project code experience, past events. Past events. Intro to Python and data science. So it should already be right somewhere in here. There. I only say that because I don't need people to remember my username, but I will post it in there for the Codex Python workshop. So it's just going to be in here under day one intro or command line or something like that. The code that I ran for the introduction from Tuesday, the machine learning big data introduction, is already there. If you want to see what Python can do and you're just getting started, go check out the Teapot intro and the Boston model.ipython notebook file. The whole thing is annotated, so you can. We're going through and explaining. Here's what the code is about to do. Here's the code. Here's its output. And next step. Let's look at our data set. Well, we're putting it into pandas, and then here's what the data set looks like. Okay, well that's great. Now we're creating a model. Here's the model that was created, so on and so forth. So that's it. I will see you wonderful people next Sunday, where we're going to actually look at some data analysis with pandas.
Question.